Safety Toolbox Talk number 258. BowTie Analysis. BowTie Analysis is a popular risk assessment tool used to visualize the relationship between potential hazards, their causes, preventive and mitigative controls, and possible consequences. Here's a detailed 1. Purpose of BowTie Analysis. Visual representation. It provides a clear, graphical depiction of how hazards can lead to incidents, and the controls in place to prevent and mitigate them. Risk management. Helps identify and assess risks, ensuring that adequate controls are in place to prevent and mitigate potential incidents. 2. Structure of the BowTie diagram. Hazard. The central focus of the diagram. It is the source of potential harm or an undesirable event. Top event. This is the critical event that occurs when a hazard is released or control is lost, leading to an incident. The knot of the BowTie represents the top event. Threats. On the left side of the BowTie, these are the possible causes or scenarios that can lead to the top event. (3) Preventive controls. Definition. Controls or barriers placed on the left side of the diagram to prevent the threats from causing the top event. Examples: engineering controls, e.g. safety devices, procedural controls, e.g. training, and administrative controls, e.g. safety policies. 4. Mitigative controls. Definition. Controls or barriers on the right side that aim to reduce the severity or impact of the consequences if the top event occurs. Examples: emergency response plans, containment systems, or safety systems that activate after the event. 5. Escalation factors. Definition. These are factors that can weaken or bypass the controls, making them less effective. Escalation factor controls. Additional barriers or controls are put in place to prevent escalation factors from undermining the primary barriers. (6) BowTie construction steps. 1. Identify the hazard. Start by defining the hazard that could potentially lead to an undesirable event. 2. Determine the top event. Identify the critical event that occurs if the hazard is realized. 3. List threats. Identify all possible causes or scenarios that could lead to the top event. 4. Identify consequences. Determine the potential outcomes if the top event occurs. 5. Establish preventive controls. List controls or barriers that can prevent threats from leading to the top event. 6. Establish mitigative controls. Identify controls that can mitigate the impact if the top event occurs. 7. Analyze escalation factors. Identify factors that could weaken your controls and establish additional measures to prevent this. (7) Advantages of BowTie analysis. Simplicity, easy to understand and communicate to stakeholders, making it suitable for workshops and group discussions. Comprehensive, provides a clear overview of the risk, including preventive and mitigative measures. Focus on controls, highlights the importance of controls in preventing incidents and mitigating their impact. 8. Limitations of BowTie analysis. Static nature. The analysis represents a snapshot in time and may not account for dynamic changes in risk factors or controls. Complexity with large systems. For very complex systems, the diagram can become overcrowded, reducing clarity. Does not quantify risk. While it qualitatively assesses risk, it does not provide a quantitative risk measure. (9) Applications of BowTie analysis. Safety management, commonly used in industries like oil and gas, aviation, and chemical processing to manage safety risks. Environmental risk, helps identify and manage environmental hazards and their potential impacts. Operational risk, can be applied to various operational risks, including financial, supply chain, and project management risks. 10. Best practices. Involve stakeholders, engage a multidisciplinary team to ensure all potential threats, consequences, and controls are identified. Regular review. Update the BowTie analysis periodically to account for changes in the system, new risks, or the effectiveness of controls. Integration with other tools. Use the BowTie analysis in conjunction with other risk management tools like HAZOP, Hazard and Operability Study, or FMEA, Failure Mode and Effects Analysis, for a more comprehensive risk assessment. Thank you.